Hi, um, welcome to this lesson. So, this lesson is gonna be about number pattern as you gave me on the list of your topics that you'll be doing. So, I decided to start with the number pattern. So, I don't know if you've done it at school, but I'm just gonna go through some few concepts and some examples. If you will have any questions, then please try to look at what you've done in school, and then you can just tell me if there's anything you don't understand. Okay, so in number patterns, we talk about linear pattern, and then we talk about quadratic pattern. No, not quadratic, but the second one is geometric pattern, and then the third one is quadratic pattern. So we're gonna look into each and every pattern here and see how they are different. But for this lesson only, I'm gonna focus on linear number pattern. So linear number pattern we know that it consists of two things. The first one, we know that in linear number pattern we look at constant difference, and the second part is the general rule. So what is the general rule of the linear pattern? The general rule of the linear pattern is Tn is equals to En plus B. So when we look at the constant difference is symbolized by the variable d. So that is the constant difference. It's the number that you keep on adding on the pattern so that your pattern continues. Okay, let's look at examples of the linear number pattern. Linear number pattern can be like of the form of 3, 5, 7, 9, 11, and going on. So by looking at this pattern here, or we can call this a sequence because it's numbers, we have the terms such as T1, T2, T3, T4, and T5. So these are the terms in this sequence. So if we look at this pattern and we want to find the constant difference, it means that we find common difference by saying T2 minus T1, which is equals to 5 minus 3, which will be 2. And then we do again with T3 minus T2, which is 7 minus 5, and this will give you 2 as well. And if we keep doing the same thing, let's check. Oh no, I'm sorry, this was supposed to be T4, not T3. So let me just say T4 and then T5. Okay, so if we continue using the same method, we can say T4 minus T3, it will give you 2. And then T5 minus T4, it will give you well, I can't just say 2 here because I need to do the real subtraction, and here it has to be 9. Our T4 is 9 minus 7, which will give me 2. And then our T5 is 11, and our T4 is 9, which will give me 2. So you can see that our difference is the same, it's not changing, it's 2 everywhere. So then in conclusion, we can say that the constant difference of this pattern over here, which is D, will be 2. Right. So now let's look at another example. We have 5, 9, 13, 17, and so on. So we're gonna do the same thing again to find our common difference or our constant difference, because we know that it has to be the same. So in this case, I'm just gonna be like 9 minus 5, which is 4. 13 minus 9 is 4. 17 minus 13 is 4. So therefore the constant difference of this pattern over here, or the sequence, is what? It's 4, which is symbolized by the value G. Okay, maybe finding constant difference is not that complicated in linear number pattern. So because you just have to subtract the terms in order for you to find the constant difference. But sometimes the sequence can be increasing or decreasing, so that means that on our first 2 patterns that we looked at, this one, it's an increasing number pattern, as you can see, 3 5 now, 3 5 7 9 going up. So this pattern is increasing, and our second pattern also is doing the same thing, it's also increasing. But what if we have a pattern which is decreasing? Like you can have a pattern which is like 25, 20, then you go 15, 10, this is 10, then 5, and so on. So looking at this pattern, it is decreasing. So this doesn't mean that when you calculate the constant difference, then you must start from right to left. No, it's the same process. You start from left to right, because here you're gonna have T1, T2, T3, T4, T5. So, and then we can still find our constant difference. So it means that our constant difference in this case is going to be a negative number. So it's still possible to get a negative number as a constant difference. So how do we do that? We're going to have our T2 minus T1, which is 20, minus 25, and then we know that our answer is is negative 5. And then tier 3, this is 3, it's not 5, it's just, yeah, it's 3. Tier 3 minus T2, which is 15 minus 20, which will still give you negative 5. T4 minus T3, which is 10 minus 15 is negative 5. So you can see that we are getting a constant difference, which is negative in this case. So it means our pattern is decreasing, hence we're going to get a constant difference of a negative number. Okay, so if you are to describe this pattern, like what is happening here. So here, to generate this sequence, it means that you're starting from 25, and then you add negative 5, and then you can see that 25 positive multiplied by negative will give you negative, then you're gonna get 20. And then the same thing to get the second pattern, or the second term, or the following term. Since here you started with 25, then you added negative 5, you got 20. Then let's say you have 20, then you add negative 5, which is going to give you 20 minus 5, and then that will give you 50. That's our third term. So keeping on adding negative 5 and until we get to this point here, or up to infinity. Okay, so these are just ways of finding a constant difference in a linear number pattern. Okay, so like now we can go into our second part of our linear pattern, which is the general rule. This rule can be called as the nth term, not the nth term, but just the nth term. The nth term, or we can call it Tn. It's the same thing. So how do you find the general term of the linear pattern when you are given a pattern? Okay, let's look at our first example that we used. We had 3, we had 5, we had 7, we had 11, and so on. And we want to find the general term of this pattern. So we remember I said that the general term of the pattern, or of the linear pattern, is written in the form of Tn is equals to An plus B. So what is happening in this formula? In this formula you can see that Tn stands for the nth term. So this is the nth term. It means that for n, I can replace it with any number. It can be 1, it can be 2, so it's the nth term, or 10, or so on. So it is the position of the term in the sequence. So it means that if I want to calculate any position of the term, then I use, it is symbolized by Tn. Then we have the A, the value A. The value A usually it's our constant difference. So our constant difference is multiplied by the n, and then the n represents what? The term number. So term number 1, term number 2, and so on. And then b is our constant number. It's not the constant difference, but it's the number that you add after this product. So let's see how does this work when we are using this example over here. So I'm just gonna draw a line over here. Yeah. So okay, I want to find the general rule for this number pattern over here. So don't forget, this is T1, T2, T3, and T4. Okay, up to the last term, which is Tn. So I have something like T1, which is equals to 3. Okay, so how do I get T2? Right, my pattern starts at 3. How do I get T2? To get T2, it means that let me start by finding what? Constant difference. So the value T is equals to T2 minus T1, which is 5 minus 3, which is equals to 2. We had to do that again, but you know we did it on the previous example, but just to repeat that again. So you know, okay, just to calculate T to constant difference, you have to do that twice so that you are sure that you're getting the same value. So I'm gonna do the same thing for T3 minus T2, which is 7 minus 5, and then it's 2. So now I am sure that the difference is the same, it's constant, and the value of that is 2. Okay, so I said that my first term is 3. So in order for me to get the second term of this sequence, T2, right, it means I will have 3, and then what, plus what, I add the constant difference, plus 2, which is equals to 5. Okay, that's my T2. Okay, fine. So now let me do something here. I'm just gonna start a new page, and then remember, let me rewrite our pattern here so that it's 3, 5, 7, and 11, and then go on. So, and then our constant difference is 2. Okay, our general term is that number plus b. So we need to find the value of a and b. Okay, fine. So I have T1. Remember I said a is actually a constant difference, which is 2 in this case. So I'm gonna say 2. Then n is 1, because as you can see Tn is 1 here. Then I'm gonna replace that by 1. So the main aim is to get 3 here. So which number do I add plus b? I need to find that number here, which is b, that I will add with this product to get 3. So I know 2 multiplied by 1 is 2, and then plus b. So if you are reasoning properly, then you will see that to get 3, it means you need to add 1. So you have 2 plus 1, and then that will give you 3, and then 3 is our first term. Okay, that's cool. Let me repeat again for the second term. Okay, T2. Our constant difference is 2. The value of n is 2. Then plus b. Then 2 multiplied by 2 is 4. But then our second term is 5. So which number do I add to 4 to get 5? Is 1, which will give me 5. Okay, cool. So sometimes you don't have to always guess the value of b in all cases. As you can see here, I can say that the value of b is 1 or plus 1, because I am adding 1 in every product here. Okay, so but then do I always have to guess that the value is 1, or do I have to always guess the value of b? No, not really. Okay, so let me find another way to make calculating b easier, and not to just guess it, because yeah, I know that I have to get the value 5. So if I multiply 2 by 2, I get 4, but 4 plus 1 will give me 5. Okay, but what if the sequence is too complicated and maybe guessing the value of b, it's tricky? Okay, so this is what happens. I'm gonna do the same thing here and say that T1, right, is 3. We know that T1 is equals to 3, right? So I'm taking this over here, and then I'm gonna substitute this T1 by 3. So if I take this equation, which is T1 is equals to 2, don't forget that 2 is our constant difference, plus b, right? So I know that T1 is 3. I put 3 instead of T1. Then I have 2, because 2 multiplied by 1 is 2. And then I have plus b. So when you're at this point, you can see that, oh man, I can just solve for the b. I can solve for b. Okay, how do I do that? You know that, you know algebra. So you just say like terms on the other side. So as you can see, you only have one variable, which is b, so the rest is the numbers. So like terms, group them on the other side. So then it means it's 3 minus 2. Remember, don't forget, when the number goes to the other side of the equation or equal sign, you will change the sign. Then 3 minus 2 is equals to b. Okay, so 3 minus 2 is 1, right? Which is equals to b. Therefore, you can see that, oh, the value of b is equals to 1. Okay. Let me repeat the same thing using our second equation here. I'm gonna take this equation and do the same thing to show that the value of b is gonna be the same. Okay, right? So we have that T2 is equals to our constant difference and our term number, which is 2 plus b. we know that T2 is equals to 5, right? And then 2 multiplied by 2 is 4 plus B. And then group this into like terms, then you will see that 5 minus 4 is equals to B. 5 minus 4 is 1, which is equals to B. Then therefore B is equals to 1. Okay, hi. You can see that, oh, there, it's very simple to find the number or the value of B. Let me do again for the third term, which is T3. We know that our constant term is 2, our term number is 3, and we do not know the value of B. Our term or our third term is 7, and then 2 multiplied by 3 is 6 plus B. 7 minus 6 is equals to B. Then I have 1, which is equals to B, and then therefore B is equals to 1. So you can see we are getting the same value of B. So therefore, how do you write your general formula there? You know that the value of A is the constant difference, which is equals to 2. Our Tn is just the term number, or our general term number, and then the value of B is 1 because we calculated it. So writing my general rule in full, it will give me that for Tn, the value of A is 2, then n is n because I'm not specifying a term number in this case, then plus 1. Okay, so that means that the general rule or the rule for our sequence, which is 3, 5, 7, 11, is Tn is equals to 2n plus 1. Okay, so to make sure that your rule is correct, you must always test it so that you know that you did the right thing. So okay, let's test this rule and see if it works. Okay, we know that our Tn is equals to 2n plus 1. So I'm gonna test it for T4. Don't forget our T4 is 11, right? So I'm gonna see if I'm gonna get the same thing. Yeah, is our T4 11? Let me check, let me confirm. 1, 2, 3, 4. Oh yeah. Okay, so it's not 11, it's not 11, it's not 11. I made a mistake, it's not 11, but it's 9. It's 9, it's 9, guys. I'm sorry, it's 9. Yeah, it's 9. Then the fifth one, the one where it's 11. Okay, so we're gonna substitute our value of n by 4, then we say plus 1, and then I'm gonna get 2 multiplied by 4, which gives me 8, plus 9, which will give me not plus 9 but plus 1, which will give me 9. Okay, so maybe let me do again for T3 just for surety. 2 multiplied by 3 plus 1, which is 2, times 3, which is basically 6 plus 1, which gives me 7. And we know that our T3 is 7. Okay, so yeah, that's how you calculate the general rule for this number pattern of a linear number pattern. Okay, so I'm gonna write down an example so that we can see exactly how do we work with linear equations. Okay, so they gave you the sequence, which is 3 and 8 and 13. Okay, so first question says write down the next term of the sequence. Second question says describe the pattern in which, okay, in which. Number 4 says write down the general term of the given sequence in the form of Tn is equals to. The fifth one says, okay, I'm gonna stop right there because the fifth one is a bit tricky. It's something that we will do after this. So let's look at this question. So in maths, you must always read and understand the questions. Do not just start to answer without understanding what is going on. All right. So we are given a sequence here. Since we are working with a linear equation, so obviously this sequence is linear, but you must always make sure that it is a linear equation. So first question says write down the next term. It's like 1 mark, you know. The next term can be x, just 1 mark. Okay, but how do you do that? You can, there's always ways to do this, you know. You don't have to just you know, cram or something like that. But then what I'm gonna do now is that in order for you to do the right thing and not guess, let's try and find the constant difference first. So constant difference, which is d, is equals to t2 minus t1. t2 minus t1, which is 8 minus 3. 8 minus 3 is equals to is 5, and then t3 minus t2 is equals to 13 minus 8, which also gives me 5. So always do this for the sequences that you're given, because if you're just gonna do this only once, you're not gonna get the right, or you won't be sure whether this is a linear sequence or not, because usually the constant difference is written in this way: t2 minus t1 is equals to t3 minus t2. Okay, this is to confirm that our difference is constant, it's the same, it's not changing. As we can see, once you find that this is 5, you also found that this is 5, so obviously our d is equals to 5. So you go back to answer the question now. We said the value of the next term is x, but now we can actually find it. It means that in order for me to get the next term, I need to add 5 in this one. So it means that The next term is 18. It's 18 over here. Just 1 mark. So they don't care that you had to go through this. Like I said, maybe someone can just say, yeah, you can just do this in your head, and then you start here, you say, oh, I started with 3, then 4, 5, 6, 7, 8. Oh, you see, okay, plus 5, I got 8. Then you say, oh, now you're at 8. How do you get 13? 8, 9, 10, 11, 12, 13. Oh, 5. So it means to get the next one, it's the same thing. 13, 14, 15, 16, 17, 18. Okay, cool, that's it. But someone can prefer to calculate the first difference or the constant difference anyway. But there's always different ways to kill a cat. Okay, let's move to the second question. The second question says, describe the pattern in words. Okay, let me just go to the next page. So how do you describe the pattern in words? This one is simple, you don't have to think too hard. It's the same thing that you did, adding 5 in the following term. So how do you answer that? Add 5 in the following term. The main word or the key point here is just to add 5. That's the most important thing here that you need to point out. Add 5 in the following term. Or to get the next term of the sequence, you add 5. So that's how you describe the sequence in word. And then our question, which is the memorized question of the question, or our main thing to focus on, is this one. Write down the general term of the given sequence in the form of Tn. So what does that mean? Please always follow the instructions. Do not write other things if they didn't tell you to write that. So here, as you can see, they gave you the format of writing down that question. So your question must start with Tn is equals to. So in your answer, you must have this. Okay, right. So remember, our constant difference is 5, and then let me start it off like this. Our general formula of a linear equation is this. Okay, then the given information in this formula is that D, which is the same as A from the formula, is equals to 5. And our job is to find the value of B. Okay, so N represents any term number. Okay, so we're gonna do the same thing that we did in examples, starting with T1. We know that T1 is equals to 3, right, which is 3. So using this formula, we know that T1 is equals to, the value of A is 5, and we don't know the value of B, but I can substitute T1 by 3. So in this equation, I'm going to have 3 is equals to 5, then the value of N is 1, because as you can see, 1, so is 1 plus B. Okay, right. So I'm gonna have to solve B. 3 minus 5, because 5 multiplied by 1 is 5, is equals to b. So 3 minus 5 is negative 2, which is b. Okay, let me do the same thing for the second term, t2. T2 is 8, right? And then we know that T2 is equals to our general term, or our constant difference, which is 5 multiplied by 2 plus b. Okay, then 8, T2 is 8. Remember that is equals to 5 multiplied by 2 is 10 plus b. So 8 minus 10 is equals to b. So therefore the value of b is equals to negative 2. So you can see that our value of b is the same, is negative 2. Okay, so that means that my Tn is equals to what? 5a, no, not a, but n, because 5 is my constant difference, minus 2. Okay, so that is the answer for this question. So okay, note the following. Our value of b is negative. Does not mean that our sequence is decreasing. No, because you can see our sequence is increasing, starting at 3, then it went to 8, and then it is at 13, and then it went up to 80. So that doesn't say anything about the value of b. The value of b is just a number that you add in this product that will give you the term number. So like I said, this is the answer for the question, but it is always important to test your solution. So in order for you to make sure that your answer is correct, we can test this. So let's test this by let's calculate T2. Don't forget our T2 is equal to 8. So it means that using this formula, I must get 8. Okay, so T2 is equals to 8. Then I say 5 multiplied by 2, because our value of n is 2. Then minus 2. 5 times 2 is 10. 10 minus 2 is 8. See, I found that the value 8 using the formula. So I'm not gonna go do this for other terms. You can also test the other remaining terms, but by just doing this for one term and you get the correct answer, then it means that your formula is correct. So it means that the answer for our formula is this one. Okay, in number patterns, they will always ask you to calculate the term number in the sequence. Usually this question follows after you found the general rule for the term or for the sequence. So this is also simple, but with practice you will easily see that it's not really complicated. This is different from calculating a value of a term. So let's go back to our question. We know that we have our sequence, which is 3, 8, 13, and then our new term, which is 18. And the general rule of this term is 5n minus 2. Okay, so usually after you found the general rule of the term, they can ask you something like find the 20th term of this sequence, or calculate. So since you have the formula to calculate this sequence, then it means that you can find any term in the sequence, any term, because now they gave you the n, the 20th term. Okay, I'm not addressing this topic not yet. I'm still trying to give you 4 other ways to use this formula. So this is the question that follows after you have found the formula of the sequence. So it means that for the 20th term, you'll have T20, which is 5, and then you have 20 minus 2. Then that will be 20 multiplied by 5 is 100 minus 2, which is 98. So that is the term number 20. So if I was to write all the terms of this sequence up to the term number 20, I was gonna land on 98. But since this will take us the whole day, that is why we had to use the rule. So I can again maybe calculate T number 200. Okay, T number 200. So it means the value of n now is 200. So 5 multiplied by 200 is 1. Ooh, mistake. Is 5 minus 2. Not forget that. Is 1000 minus 2. 1000 minus 2 is 998. So again, if I was to continue writing down all the patterns or all the terms of this sequence, I was gonna up to 200, then I was gonna land in this field. But since this will also take us the whole day, hence we had to find the formula to calculate the number of terms. So here it's simple and straightforward. You just note the number of n, or the value of n, and then you substitute it on the formula, then you get your answer. So coming back to this question over here, our question. So let's say the question asks you which term of the sequence is 38. Guys, this is sequence, please. My handwriting is just not coming out right this time. But which term, or let me say which term, this is term here. Which term of the sequence is 38? So so that means that this is different now. This is different. It's not the same as the first find the 20th term of the sequence. Now they gave you that there's a value, or there's a term in the sequence which is equals to 38. So if you are to write down all the terms of this sequence, you are gonna get to somewhere where you will find 38. But now, which term in this sequence will give you 38? Okay, so instead of also doing this thing of writing down all the terms of the sequence up to until we find 38, we're just gonna use this formula over here. So now I'm gonna show you how to use this formula in order for you to answer this question. Okay, here on this one we had to just substitute the value of n, and then we just calculate the term number. But in this case, you're not calculating the term number, you are calculating where in the sequence you're gonna find this value. But here you were calculating what is the value of the T20, right? You are calculating the value of T20, which is 98. But if the question was like, which term number is equals to 98, then you're gonna do it other way around. Okay, so I'm gonna do that. Okay, so using our formula here, which is Tn is equals to 5n minus 2, then it means that this number here will be substituting Tn. So my Tn is equals to 38. Not n, but the whole thing. Tn is 38. N is an unknown value. Okay? Then, so, which means that you're gonna have something like 38 is equals to 5n minus 2. This is what you're gonna have. Okay, so let me go on to the new page so that this can be clear. So remember, Tn is equals to 5n minus 2, and then I said that Tn is equals to 38, and I had to write that 38 is equals to 5n minus 2. So I need to find this value over here. This is the value that I need to find. Okay, so in maths is always the same, nothing changes. The only thing is just to understand what they need you to do. Because if I look at this question says which term of the sequence is 38. So one thing about number pattern is for you to be able to take the information written in words and put it in the formula. Once you put it in this formula, then the rest is maths. Then from here to find the value of maths, it's up to you knowing how to solve for a variable, like solve for x or anything like that. So here you can just take it as a solve for x, but in this case we don't have it for x, but we have n, so which is the same thing, variable. So here you just have 38 group-like terms, which is plus 2, because as you can see you have negative 2. When it goes to the other side of the equal sign, it will change the value and becomes positive. And then you're gonna have 5n. Then 38 plus 2 is 40, which is 5n. Okay, now what do you do in order for you to have n, or to solve for n, which is divide both sides by 5. 5 will cancel 5, then you will have that 5 into 40 is 8, then n. So that means that the value which is equals to 38, or the term number 8 is equals to 38. Okay, you answered the question, but the answer is right here. So you calculated the value of n, which is equals to 8. Okay, so let me prove that indeed 8 is there. It will give me the term of 38, or term number 8 will give me 38. So using our formula again, so it means that my Tn is equals to 5n minus 2. Then I take the value of n here, which is T8, which is 5 into 8 minus 2, and then 5 multiplied by 8 is 40 minus 2. Then I can see that 40 minus 2 is 38. So indeed the n, or term number 8, is equals to 38. So I'm gonna stop right here on the linear equation or linear number pattern, and like I said, if you have any questions or things that you don't understand, please text me, send me WhatsApp, screenshots, or anything from your schoolwork. Yeah, thanks.